Welcome everyone. Today we are going to discuss about the Graham's law of diffusion. Graham's law of diffusion states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass or its relative atomic mass. That is Graham's law of diffusion. So from the law, it states that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass or its relative atomic mass. So let's just call it M. If I have to remove the proportionality sign and replace it with a constant, I will have R is equal to K multiplied by 1 over root M. So that will be R is equal to K all over root M, where R is the rate of diffusion of the gas, M is the molar mass or the relative atomic mass, and K is the constant. So therefore we can say K is equal to R root M. If we have different gases but are subjected to the same temperature and pressure, let's say one of the gas is gas number 1 and the other one is gas number 2. Since K is constant, we can say R1 root M1 is equal to K and R2 root M2 is equal to K. So that implies that R1 root M1 is equal to R2 root M2. Okay, so if I try to bring the R's in one side of the equation, let's say we divide both sides by R2. So this will cancel this. That is, I will have R1 root M1 all over R2. This is equal to root M2. So let me try to bring the M to the right side of the equation. Then I will divide both sides by root M1. So this will cancel this. That is R1 all over R2 is equal to root M2 divided by root M1. Now, what does this mean is that the rate of diffusion of gas 1 is inversely proportional to its molar mass, as well as the rate of diffusion of gas 2 is inversely proportional to its molar mass. Okay? And remember that rate is when you divide anything by time. So it can be volume divided by time. It can be concentration of a substance divided by time. It can be the mole divided by time. Okay? So what I just want you to understand is the rate actually explains how fast or slow something is. So if we are talking about the rate of diffusion of a gas, we are actually referring to how fast or slow the gas is diffusing. So if we consider this equation, it means that the rate of diffusion of gas 1 with respect to gas 2 is given by this expression. So whatever value we have from this, it means that gas 1 is that times faster than gas 2. All right? So sometimes you may not be given rate, you will be given time. And if you can see here, rate and time are inversely related. Okay? Rate and time are inversely related. So if rate and time are inversely related, it means that time and molar mass will be directly related. That makes sense, right? So it means that time is equal to volume divided by rate. Okay? And time, therefore, will be directly related to the molar mass. So that is, we will have time 1 all over time 2 is equal to the root of m1 all over the root of m2. Okay? This is also an important formula to consider. Another formula to note is when they give you density, it is important to know that density and molar mass are also inversely related. So density of gas 1 all over density of gas 2 is equal to the square root of the molar mass of gas 2 divided by the square root of the molar mass of gas 1. All right? We will be solving some problems related to Graham's law of diffusion. We have a question here that reads, ammonia gas and hydrogen sulfide gas are made to diffuse under the same conditions. Which gas will diffuse faster? Explain your answer. State the law you base your answer on. So here we have two gases, ammonia gas, which is NH3, and hydrogen sulfide gas, which is H2S. We want to determine which of these two gases is going to diffuse faster, okay, at the same condition. And when we talk about the same condition, we are talking about the same temperature and pressure. So which of the gases will diffuse faster? The first thing I want you to know is the lighter the gas, the faster the rate of diffusion. That is to say, the smaller the molar mass or the relative atomic mass, the faster the rate of diffusion. Okay? So that is how you can state the gas that will diffuse faster. If it is having a smaller molar mass, it will be the gas that will diffuse faster compared to the gas that is having a higher molar mass. If the molar mass is high, then the gas is heavy. If the molar mass is low, then the gas is light. Now let us try to determine the molar mass of ammonia. That will be N, which is 14, as the atomic mass of nitrogen, plus we have 3 here. That will be multiplied by the atomic mass of hydrogen is 1. So we will have 17 grams per mole as the molar mass of ammonia. So what is the molar mass of hydrogen sulfide? We have 2 here. That will be multiplied by the atomic mass of hydrogen is 1, plus the atomic mass of sulfur is 32. So we will have 34 grams per mole. As you can see, ammonia has a molar mass of 17 grams per mole, and hydrogen sulfide has a molar mass of 34 grams per mole. So because the molar mass of ammonia is lower than the molar mass of hydrogen sulfide, it means ammonia is lighter than hydrogen sulfide. So ammonia is going to diffuse faster than hydrogen sulfide. Okay? So that is the molar mass. It is 17 grams per mole. But if they ask you the relative atomic mass is just 17. Okay, it has no unit. All right. So what is the relative atomic mass of hydrogen sulfide? It is just 34, because you are considering the mass of that compared to the mass of carbon 12 atom. So straightforward, we can say that ammonia diffuses faster than hydrogen sulfide gas. All right. So let's try to determine how many times is ammonia faster than hydrogen sulfide. So according to Graham's law of diffusion, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. So if we're talking about the rate of diffusion of ammonia gas compared to the rate of diffusion of hydrogen sulfide gas, that will be equal to the square root of the molar mass of hydrogen sulfide gas all over the square root of the molar mass of ammonia gas. So that is the rate of diffusion of ammonia gas all over the rate of diffusion of hydrogen sulfide gas is equal to the square root of the molar mass of hydrogen sulfide is calculated as 34 all over the square root of the molar mass of ammonia is calculated as 17. So that is the rate of diffusion of ammonia gas all over the rate of diffusion of hydrogen sulfide. This is equal to the square root of 34 all over 17. So we'll have the rate of diffusion of ammonia gas all over the rate of diffusion of hydrogen sulfide gas is equal to the square root of 2. That is the rate of diffusion of ammonia gas all over the rate of diffusion of hydrogen sulfide is equal to 1.4. So because this is a ratio, it means that ammonia gas diffuses 1.4 times faster than hydrogen sulfide gas. Okay, ammonia gas diffuses 1.4 times faster than hydrogen sulfide gas. And the law that is associated with this is the Graham's law of diffusion. So if you are asked to state it, you have to state it completely. It states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass or its relative atomic mass. So moving on to the next question that reads, 300 centimeter cube of hydrogen gas diffuses through a membrane in 25 seconds. How long will it take 720 centimeter cube of oxygen gas to diffuse through the same membrane? Hydrogen is equal to 1, oxygen is equal to 16 as the atomic masses. Solution. Here we are dealing with two gases. We have hydrogen gas and oxygen gas. The volume that is given for hydrogen gas is 300 centimeter cube that diffuses in 25 seconds. The volume that is given for oxygen gas is 720 centimeter cube, and we are asked to determine the time it will take to diffuse through the same membrane. Well, here we have to apply the Graham's law of diffusion. Now, if you are given volume and time, you can be able to find the rate. So the rate of diffusion of hydrogen gas will be the volume of the hydrogen gas all over the time taken for the hydrogen gas to diffuse. That will be 300 centimeter cube divided by 25 seconds, and 300 divided by 25 is 12, so it means 12 centimeter cube per seconds is the rate of diffusion of hydrogen gas. So what actually does this mean? 12 centimeter cube per seconds, it means that in 1 second, 12 centimeter cube of the volume of hydrogen gas will be diffused. That is actually what the interpretation is. So I can try to find the molar mass of hydrogen gas. So what will be the molar mass of hydrogen gas? That will be M is equal to, we have 2 here, so that will be multiplied by 1. That is 2 into 1. The molar mass of hydrogen gas is 2 grams per mole. So what is the relative atomic mass of hydrogen gas? Is just 2. Alright, remember, the relative atomic mass does not carry any unit, but the molar mass will carry a unit as in grams per mole. Alright, so what is the molar mass of oxygen? So that will be M is equal to 2 into oxygen is 16 as the atomic mass. That will be 32 grams per mole. So I already know 3 parameters. I know the rate of diffusion of hydrogen gas, I know the molar mass of hydrogen gas, and I know the molar mass of oxygen gas. It means that I can be able to determine the rate of diffusion of oxygen gas. All right. According to Graham's law of diffusion, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. So the rate of diffusion of hydrogen gas all over the rate of diffusion of oxygen gas will be in inverse proportionality. That will be the square root of the molar mass of oxygen gas all over the square root of the molar mass of hydrogen gas. Look at it. The relationship will always be inverse. All right. So what is the rate of diffusion of hydrogen gas? We calculated that as 12 centimeter cube per seconds divided by the rate of diffusion of oxygen gas, which we are trying to find. This is equal to the square root of the molar mass of oxygen gas is calculated as 32 divided by the square root of the molar mass of hydrogen gas is 2. So that is 12 divided by the rate of diffusion of oxygen gas is equal to the square root of 32 divided by 2. So that is 12 all over the rate of diffusion of oxygen gas is equal to the square root of 32 divided by 2 is 16. So we'll have 12 all over rate of diffusion of oxygen gas is equal to square root of 16 is 4. So what do? We cross multiply. And if we cross multiply, we'll have 4 times the rate of diffusion of oxygen gas is equal to 12. That is 4 rate of diffusion of oxygen gas is equal to 12. So to find the rate of diffusion of oxygen gas, we divide both sides by 4. So that is the rate of diffusion of oxygen gas is equal to 3 centimeter cube per seconds. All right. But that is not the final answer. Remember, the question asks us to find the time. But we know that rate is equal to the volume divided by time. So that is to say, the rate of oxygen gas is equal to the volume of the oxygen gas divided by the time it takes for the oxygen gas to diffuse. So if I cross multiply, I will have rate of diffusion of oxygen gas multiplied by the time it takes for oxygen gas to diffuse. This is equal to the volume of the oxygen gas. So to make T the subject of the formula, I will divide both sides by RO2, RO2. This will cancel this. So it means the time it takes for oxygen gas to diffuse is equal to the given volume of the oxygen gas divided by the rate of diffusion of oxygen gas. What is the given volume of oxygen gas? In the question, the given volume is 720 centimeter cube. All right. 720 centimeter cube divided by the rate of diffusion of oxygen gas. We calculated that as 3 centimeter cube per second. 3 centimeter cube per second. So centimeter cube cancels centimeter cube. That is going to be 720 divided by 3, and that is 240 seconds. Okay, and that is the time it will take for oxygen gas to diffuse. Thank you very much for watching this video. If this is the first time of visiting this channel, please subscribe to the channel, like our videos, and you can share them.